Hello students, in this class we will discussing the some problems related to the chapter atoms, and also we will give an important to solve the some problems related to the CET, JEE or NEET. Students, the first problem is here. When an electron in hydrogen atom when an electron in hydrogen atom is excited from its fourth orbit to the fifth stationary orbit, the change in angular momentum of the electron is here given. The Planck's constant h is equal to 6.6 into 10 to the power of minus 34 joule second. See here the given the n2 and n1 values. Here n2 is more, that is here n2 is 5 and n1 is 4. When an electron transition takes place from one orbit to the another orbit, there must be some change in angular momentum. That change in angular momentum is calculated here by using the Bohr's quantization rule. What is meant by Bohr's quantization rule? According to the Bohr's quantization rule, the orbital angular momentum of an electron, that is L, is equal to how much? It is equal to the integral multiple of h by 2 pi. That means here students, by using Bohr's quantization rule, we can calculate the orbital angular momentum of an electron in different orbit. For example, we know that L is equal to the nh by 2 pi. This is the Bohr's quantization rule. Here n value is 1, 2, 3, 4 for different orbit. For example, for first orbit n is equal to 1, for second orbit n is equal to 2, for third orbit n is equal to 3, and so on. By using this relation, we can calculate the L. L is nothing but a orbital angular momentum of an electron in a particular orbit. By knowing the here L4 and L5 and subtracting these two, we get the change in angular momentum. That change in angular momentum is obtained by subtracting the L5 and L4. First we find out the L5 and L4 values, and always we know the relation, that is L is equal to nh by 2 pi. Students, write down the solution. Write down. We know that L is equal to nh by 2 pi. This is the Bohr's quantization rule. By using this rule, we can find out the angular momentum of the electron in a different orbit. But here they asked change in angular momentum when an electron transition takes place from 4th to the 5th orbit. We know that n value is more when the orbital, L value is more when the electron is in 5th orbit, and L value is less when the electron is in 4th orbit. Therefore, first we have to write L5, after that we have to write L4. Therefore, write down the change in angular momentum. Here we have to find the change in angular momentum. Delta L is equal to which angular momentum is more? The angular momentum in the 5th orbit is more. Therefore, L5 minus L4. Therefore, by using the above equation, we can substitute the L value, that is n5 into h by 2 pi minus L4, that is n4 into h by 2 pi. Students, by observing the above relation, we can note that here h and 2 pi is constant in both the terms. Therefore, h by 2 pi is common in both the terms. The remaining values are N5 minus N4. But here the H value is given. The H value is 6.6 into 10 to the power of minus 34. This is the Planck's constant value. Therefore, H value is 6.6 into 10 to the power of minus 34 whole divided by 2 into pi, that is 3.14 into N5. N5 means that represents the fifth orbit. In the given problem, the fifth N5 is the fifth orbit and N4 is the fourth orbit. This represents the fifth and fourth stationary orbit. By subtracting and simplifying, we get the final answer 1.05 into 10 to the power of minus 34 joule second. That means, students, by using Bohr's quantization rule, we can simplify this equation, that is this problem. That is, here most important is L is equal to NH by 2 pi, that represents the Bohr's quantization rule. By knowing the L5 and L4, we can easily simplify the change in angular momentum of the electron when the electron transition takes place from 4th to the or 5th to the 4th orbit. This is the calculated method. Students, next we will go for the next problem, that is problem number 2. See here, the first excited state of hydrogen atom is 10.2 electron volt. Its ground state, above its ground state, that is above the ground state, the first excited state is there. In that state, the energy of the electron is 10.2 electron volt. Electron volt represents the unit for energy. That is, first excited state energy is given. Next, here we have to calculate the temperature is needed to excite hydrogen atom to its excited level, first excited level. That means electron is in first ground state. When we have to give some external energy in the form of, that is temperature, then electron jumps from first, that is ground state, to the first excited state. Ground state means N is equal to 1. First excited state means N is equal to 2. Here we have to calculate the temperature. We know the relation between energy and temperature in the previous classes, that is by using kinetic energy equation, that is kinetic energy is equal to 3 by 2 kT, where K is nothing but a Boltzmann constant, T is nothing but a absolute temperature. Therefore, first here we note down the 10.2 electron volt is the energy, that is not in SI unit. Therefore, first we have to convert the given energy into SI unit. That is, what is the relation between 1 electron volt and joule? Electron volt is equal to 1.6 into 10 to the power of minus 19 joules. Write down the solution. Write down kinetic energy is equal to 3 by 2 kT. But here kinetic energy means here energy of the electron in the first excited state, that is 10.2 electron volt, that must be converted to the joule, because joule is the SI unit. And here K is the Boltzmann constant. We know the Boltzmann constant value, that is 1.38 into 10 to the power of minus 23 joule per Kelvin. By knowing these values, we can easily simplify the temperature. How much of temperature is needed to excite the electron to its first level or first excited state. Therefore, here here we have to calculate the temperature. Therefore temperature is equal to here 2 into kinetic energy. ನೋಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ kinetic energy into 2 whole divided by 3k. Next 2 into kinetic energy means here energy of the electron in the first excited state, that is given 10.2 electron volt, but electron volt is not an SI unit, therefore electron volt is converted into joule. Therefore 1 electron volt andre ಏನು ಮಾಡ್ತೀರಾ ನೀವು multiplied by 1.6 into 10 to the power of minus 19. Here 10.2 ಇದೆ, that is multiplied by the 10.2 into ಏನು ಮಾಡಬೇಕು ಸೇಮ್ 1.6 into 10 to the power of minus 19. Unit ಏನಾಯ್ತು ಈಗ ಎನರ್ಜಿ ಯೂನಿಟ್ ಜೌಲ್, whole divided by 3 whole divided by 3 into k, where k is the Boltzmann constant. The value of the Boltzmann constant is 1.38 into 10 to the power of minus 23 joule per Kelvin. Here joule get cancelled. The final answer is, by simplifying the above numericals, we get the temperature value, that is 7.9 into 10 to the power of plus 4 Kelvin. Here joule and joule get cancelled, per Kelvin ಇದು ಮೇಲ್ ಬಂದರೆ ಕೆಲ್ವಿನ್ ಆಗುತ್ತೆ. ಕ್ಲಿಯರ್? ದಿಸ್ ಈಸ್ ದಿ ಆನ್ಸರ್. That means by knowing the relation between kinetic energy and temperature, we can calculate the temperature here, and here we must know the Boltzmann constant value. That value is how much? 1.38 into 10 to the power of minus 23. That means option number A is correct here. Next we will go for the third problem. Read the problem number 3. Here electron in a certain energy level, electrons are in a certain energy level, but here the n1 and n2 values are unknown, because n is nothing but here n1 and n is treated as n2, therefore n1 and n2 are unknown. Electrons in certain energy level n is equal to n1 can emit 3 spectral lines. That means when an electron is in n1 orbit, it emits the 3 spectral lines. When they are in the another energy level, that is in n2, then it can emit 6 spectral lines. The orbital speed or orbital velocity of the electrons in the two orbits are in the ratio. That means here we have to calculate the ratio of the orbital speed or orbital velocity of the electron in these two orbits. Here we don't know the n1 and n2 values. That means they are not given the specific values of the n1 and n2. First we have to find the n1 and n2 values by using the relation, that is how many spectral lines are emitted in the given transition. That is, we know the maximum transitions or maximum spectral lines emitted is write down the solution. The number of spectral lines emitted, that is capital N, is equal to the n into n minus 1 whole divided by 2. By using this relation, we can easily calculate the number of spectral lines emitted. But here the number of spectral lines emitted is given in the two cases. That is, in first case n is equal to 3, capital N is 3, and in the second case the capital N is 6. By using these two cases we can calculate n1 and n2 values. Here n1 and n2 are unknowns. By knowing n1 and n2, we can easily calculate the v1 and v2. That means the ratio of v1 and v2 is easily calculated by using the relation, that is v is equal to z square by 2 epsilon naught nh. That is the expression for velocity, in which velocity is inversely proportional to the n. By knowing that relation, we can easily simplify the velocities. First, we have to calculate the n1 and n2 values by using these data. Students, where n represents the, capital N represents the number of spectral lines emitted, small n represents the transition, in which orbit the transition takes place. See here for the first case, we have to substitute the n. That means n is how much? For the first case, n is 3. First orbital, first case ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ನಂಬರ್ ಆಫ್ ಸ್ಪೆಕ್ಟ್ರಲ್ ಲೈನ್ಸ್ ಎಷ್ಟು ಎಮಿಟ್ ಆಗಿದೆ? 3. n1, here n is nothing but a n1, they give 1. Here n is nothing but a n1 and the number of spectral lines are 3. Therefore, we write, instead of n, we write n1, and also here n is interchanged by n1 minus 1 whole divided by 2. That becomes here n1 into n1 minus 1, that is equal to 6. By simplifying this relation, we get n1 is equal to the 3. Here, by using this relation, if we simplify, we get n1 is equal to 3 and n1 is equal to minus 2. But n is always positive because n represents here the orbital number represent ಮಾಡುತ್ತೆ. ನೀವು ಇದು ಕ್ವಾಡ್ರಾಟಿಕ್ ಇಕ್ವೇಷನ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ n1 is equal to 3 and n1 is equal to minus 2 ಬರುತ್ತೆ. ಬಟ್ ನೆಗೆಟಿವ್ ಸೈನ್ ನೀವು ತಗೋಬಾರ್ದು. ದೇರ್ಫೋರ್ n1 here 3 ಮಾತ್ರ ತಗೋಬೇಕು. ನೀವು ಮಾಡ್ತೀರಾ, ಹಿಯರ್ ಏನಾಗುತ್ತೆ ಕ್ವಾಡ್ರಾಟಿಕ್ ಇಕ್ವೇಷನ್? n into n ಸ್ಕ್ವಯರ್ minus n minus 6 is equal to 0. Therefore, by simplifying, we get n1 is equal to 3 and n1 is equal to minus 2. But minus 2 is not a considerable value because orbital number is always positive. Therefore, we must choose n1 is equal to 3. By using this method, we can also calculate the n2. That means by using the relation n is equal to n into n minus 1 by 2. Here for the second case, how many spectral lines are emitted? 6. 6 is equal to, n is equal to here n2. Therefore, n2 into n2 minus 1 whole divided by 2. Therefore, n2 into n2 minus 1 is equal to 12. Here also, we have both positive and negative values for n2, but we are choosing only positive value. That is, we get n2 is equal to 4. That means by using this relation, that is n is equal to n into n minus 1 by 2, we get both n1 and n2 values. Here next, the simplification is easy because we know the here n1 and n2 values. We know both n1 and n2 values here. Therefore, by substituting n1 and n2 values, we can easily get the v1 and v2. Students, next we also know that v, that is vn, is equal to what is the expression for velocity of an electron in nth orbit? Vn is equal to z e square by 2 epsilon naught nh. 2 epsilon naught nh. Students, here z is represents the atomic number of the given nuclei, and here E is the charge, epsilon naught is always constant, that is permittivity, n is variable, h is constant. Therefore, here velocity and orbital number both are variable. How they are related? They are inversely related. Therefore, by using this relation, we write V is or Vn is inversely proportional to n. Therefore, by using this relation, we can easily find out the orbital speed, the ratio of the orbital speed. Therefore, V1 by V2. V1 by V2 is equal to, here reciprocal, therefore it becomes reciprocal answer, that is V1 is inversely proportional to N1. Therefore, finally we get N2 by N1. But we know the values of N1 and N2. What is the value of N2? That is 4, and N1 is 3. That is 4:1 is the right answer. That is in your options, the first option, that is A, option A is the right answer. When an electron transition takes place from two unknown orbits N1 to N2, then 3 and 6 spectral lines are emitted, then we can easily calculate the speed of the ratios of the electron in the two orbits. Students, next we will go for the fourth problem, in which read the problem. Read the problem number 4. The radius of electrons second stationary orbit in Bohr atom is r. That means the radius of the electrons in the second orbit is given, that is r. That is r represents the radius of the electron orbit in the Bohr's second orbit. See here, the radius of the third orbit will be, andre first second orbit na radius r anta kottidare, third orbit radius enagutte. Generally we know that the radius of the orbit goes on increases with increase of the orbital number. First radius ginta second orbital radius, third orbital radius, fourth orbital radius goes on increase ಆಗ್ತಾ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಬಟ್ ಅದೆಷ್ಟು ಅಂತ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ ಎರಡು ಆಪ್ಷನಲ್ಲೂ ನಿಮಗೆ ಜಾಸ್ತಿ ಇದೆ ನೋಡ್ಕೊಳ್ಳಿ. ದಟ್ ಈಸ್ 3 ಆಪ್ಷನಲ್ಲಿದೆ. 3R, ಆಪ್ಷನ್ ಬಿ 2.25R, ಆಪ್ಷನ್ 3 9R. ಈ ಮೂರಲ್ಲೂ ಕೂಡ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ಡ್ರಲ್ಲೇ ಇದೆ. ಅಂದರೆ ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಆರ್ಬಿಟ್ಗಿಂತ ಥರ್ಡ್ ಆರ್ಬಿಟ್ ರೇಡಿಯಸ್ ಜಾಸ್ತಿ ಇರಬೇಕು. ಎಷ್ಟು ಜಾಸ್ತಿ ಇದೆ? 3 ಆಪ್ಷನ್ ನೋಡಿದ್ರೆ 3 ಸರಿ ಅನಿಸುತ್ತೆ ನಿಮಗೆ. ಬಟ್ ಅದರಲ್ಲಿ ಒಂದು ಕರೆಕ್ಟ್ ಇದೆ. ಎಷ್ಟು ಟೈಮ್ ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಅದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದರೆ ಫಸ್ಟ್ ವಿ ನೋ ದಿ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ಆರ್ಬಿಟಲ್ ನಂಬರ್ ಆ್ಯಂಡ್ ರೇಡಿಯಸ್. ದಟ್ ಈಸ್ ಫಸ್ಟ್ ವಿ ನೋ ದಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ರೇಡಿಯಸ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಆರ್ಬಿಟ್ ಇನ್ ದಿ nth ಆರ್ಬಿಟ್ ಆಫ್ ದಿ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಗೆ ತಗೊತೀವಿ ನಾವು. ಬೋಹರ್ಸ್ ಅಂತ ನಾವೆಲ್ಲಿ ಹೇಳ್ತೀವಿ ಅಂದರೆ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದ್ದಾಗಲೇ ಬೋಹರ್ಸ್ ಅಂತ ನಾವು ಹೇಳೋದು. ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ವಾ? ದೇರ್ ಫೋರ್ ಫಸ್ಟ್ ಹಿಯರ್ ರೈಟ್ ಡೌನ್ ದಿ ಸೊಲ್ಯೂಷನ್. ದಟ್ ಈಸ್ ಫಸ್ಟ್ ವಿ ನೋ ದಿ expression for radius of an electron in nth orbit, that is Rn is equal to, what is the expression? 5 marks derive madidira, epsilon naught n square h square whole divided by mz pi e square. This is the expression for radius of the electron. Students, here we observe that epsilon naught h or h square m z pi e, these are all the constant. 1 2 3 4 5 6 terms are constant, but only variable is n square or n. Therefore, by increasing the n, the radius of the orbit is also increases. But here we have to calculate what is the radius of the electron orbit in the third orbit of hydrogen atom. Therefore, by seeing this relation, we can write Rn is directly proportional to n square, because in the remaining terms always constant. That is for hydrogen atom. Z is always constant, that is Z is 1. Therefore, here we know the here R1 value. What is the R1 value? That is the radius of the electron in the second orbit of the hydrogen atom, that is R. Therefore, R1 by R2 is equal to here N1 by N2 whole square. N1 by N2 whole square. because R1 is N1 square, R2 is N2 square. That becomes N1. Here N1 means that represents here the radius of the second stationary orbit in Bohr's orbit. Clear ಆಗ್ತದೆ ಹೇಳ್ತಾ ಇರೋದು, ರೇಡಿಯಸ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ ದಿ ಸೆಕೆಂಡ್ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್, ದಟ್ ಈಸ್ ಸ್ಟೇಷನರಿ ಆರ್ಬಿಟ್ that represents the N1 is 1. And they ask the radius of the third orbit. Third orbit means here N2 is 3 whole square. Whole square. After simplifying we get 1 by 9. But here we want to know the value of R2. R2 means it represents the radius of the electron orbit in third orbit. Therefore R2 is equal to 9R1. But here the given R1 is nothing but a R. Therefore we write 9R. R1 ಅನ್ನೋದನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. R1 ಅಂದರೆ ಬೋಹರ್ಸ್ ರೇಡಿಯಸ್ನ ಆರ್ಬಿಟಲ್ ರೇಡಿಯಸ್, ದಟ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಆರ್ಬಿಟ್ನ ರೇಡಿಯಸ್, ದಟ್ ಈಸ್ ಗಿವನ್ ಇಯರ್ R. therefore here R1 is nothing but a R. R1 ಅಂದರೆ R ಅದು. therefore instead of R1 we write R. therefore it becomes